The human toll of Australia's worst bushfire disaster continues to climb. 173 people are confirmed dead, and that number is expected to rise even further.
And you'd watch one house after another just burst and blow up.
The Black Saturday bushfires were a series of bushfires that were burning across Victoria on and around February 7, 2009. The fires occurred during extreme bushfire weather conditions, which resulted in Australia's highest ever loss of life from a bushfire. Of the 173 deaths, 120 of them were caused by a single firestorm. In a firestorm, the radiant heat can rise to over 1200 degrees Celsius. In February 2012, at the Fire Test Centre in Mogo, New South Wales, an innovative test bunker was built to see if straw bales, protected by fireproof lining, could withstand the onslaught of a sustained bushfire and firestorm. The bunker, or straw house, was designed by renowned architect and designer Just Bakker. We took an eco-friendly house with Modak Board cladding, a steel frame and walls insulated with straw, and exposed it to the worst case bushfire scenario. The design included an earth roof and a single fire protected door. The test was monitored by Justin Leonard, the project leader for bushfire research at the CSIRO's Sustainable Ecosystems, with fire safety provided by the New South Wales Rural Fire Service. The house was clad with 2 layers of 10mm Modak board for the external walls, 1 layer of 10mm Modak board for the internal walls, and 20mm Modak board used for both floor and ceiling. Joints were sealed with Tremco's Tremstop fireproof sealant. The roof was covered with over 15 tonnes of earth to prevent roof ignition, normally a common problem from ember attacks. A couple of non-Modak MGO sheets were also used as a control. The whole house was wired up with sensors to relay performance data back to the CSIRO computers.
We're a little past 2/3 of the way through the radiation profile. So we've moved through the sort of the gradual build-up phase, and we're starting to get into the steeper part of the curve, where there'll be a fairly rapid ramp up of the intensity that the house receives before the full flame emerges. 30 seconds. Five, 4, 3, 2, 1, go.
The blast carried on for a period longer than a normal bushfire front would be, in order to test the house in the most extreme bushfire scenario, the Flame Zone Bushfire Attack Level, or BAL, FZ. With nothing to ignite, the gas-produced firestorm seems to just slide off the building. The heat now being thrown at this house is in excess of 1,000 degrees, hot enough to melt asphalt, metal and glass, and turn street tarmac to flammable hot liquid. The smoke coming from the building is from the sealants around the door, as the intense heat melts the sealants and fills the gaps. after nearly 40 minutes of intense temperatures between 800 and 1200 degrees Celsius, the test starts to wind down, and as the flames subside, we get to see that the house is not only still standing, but seems completely intact. The house is now left to cool down before the CSIRO team can go in and have a closer look. Incredibly, although the outside temperature was beyond 1000 degrees Celsius, the sensors inside state that the internal temperature only rose to a balmy 35 degrees. The only damage to the external cladding was a layer of fibre mesh that seems to have come loose on the control MGO board. The Modak board stood up to the test with no damage, no loss of integrity, and passed with flying colours. The CSIRO were working on the results when this video was made, so we will post this information on our website when available.